So now we will talk about some properties of logarithms, and hopefully these are going to seem very similar to the law of exponents that we had talked about earlier. Alright, so if you have multiplication inside of a logarithm, that's going to be the same thing as adding the logarithms together. If you have division, I'm sure you can guess, that's going to be the same as subtraction. And again, that's very similar to what we talked about with exponents, right? So if you have an exponent multiplied by an exponent, right, then we just add those exponents. And same thing with the division one, right? So this is where these ideas are kind of coming from. All right, if you have the entire thing that you're taking the logarithm of raised to a power, you can just bring that power out front. So that's the same as r times the log. If you take log base a of 1, well, hopefully you remember we talked about that, right? Because the point 1, 0 was on our logarithm graph. So that would just be 0. If you plug in a, when it have a base of a, then that's just going to be 1. So essentially that's going to kind of cancel out. So thinking about this one, right? So remember, if you have base a of a raised to a power, right? Well, remember you can bring that power out, and then you're multiplying by log base a of a, which we already said was 1. So that's just the exponent. And likewise, if you have an exponent, sorry, if you have like an exponential graph, right? A raised to a logarithm, right? If both bases are the exact same, then those cancel, and we're left with whatever is in the logarithm. All right. Number 8's weird. I don't really think we're going to be using it in this class. It's more for like in calculus and that kind of stuff. But just to let you see it, if you have a base raised to a power, that's going to be the exact same thing as e raised to the r ln of a. And the way that we get that is actually from this previous one right here, right? So we could have, if you notice, right, if we have a to the r, that's the same as, there we go. That's the same as e to the ln of a to the r, right? Because remember, natural log is base e, so e and e, those are going to cancel, and you'll just have whatever you're taking the logarithm of, right? And then, of course, if you have what you're taking the logarithm of raised to a power, you can just bring it out front, right? So that's how we get this. Again, not going to be super helpful in this class. It's probably more for like if you move on to calculus. All right. So last two are the ones that are pretty obvious. We've already kind of talked about. So if you have m and n are the same, then of course if you take the log of both sides with any base, that's also going to be the same thing, right? And we also already talked about that if you have a log with a base equals log of the same base, you can just get rid of the logs. All right, so let's use these properties to express the following. So we need to express the logarithms in terms of logarithms of x, y, and z, right? So basically we need to make this equal, right? In terms of means that all this is going to equal something with log of x, something with log of y, and something with log of z, right? So this is what we're trying to find. All right. So let's look at this. Well, if you go back, so you can have your, if you would like, you can have your laws of logarithms right in front of you, right? So if you notice, one thing that we have is division. So using number 2, right, we can see that this is going to be the same as, there we go, log base a of x cubed square root of y minus log base a of z squared. All right, that's using law number 2. We're using our division. Since we already have multiplication, right, we can use number 1. So log base a of x cubed plus log base a of the square root of y. Make that too a little easier to see. Good. Now, right, we can just use our exponent rules. So we can use rule number 3. So we can bring this 3 out front. So it's 3 log base a of x plus. So when you have something, if you have a root, right, if it's a square root, what power is this being raised to? Hopefully you remember that this is a 1/2, right? So you can bring a 1/2 out front. And then of course you can bring the 2 out front. So this is now in terms of logarithm of x, log of y, and log of z. Now, I'll just let you know what I do. I typically skip this middle step and I go straight to the second step. So basically what this means is, if inside of your logarithm, right, everything on top is going to be added, everything on the bottom is going to be subtracted. Everything on the top is going to be added, everything in the bottom is going to be subtracted. And that might be a better way of going about it, and we'll see in part B. So everything in the top being added, everything in the bottom being subtracted. That might be a better way of doing it. And again, we'll see in part B. All right. So now we have this log. So let's just do what I just said, right? So let's use number 1, or actually, yeah, well, we're using number 1 and number 2, kinda. So, like we said, everything in the top is going to be added, everything in the bottom is going to be subtracted. So we get log the cube root of z, positive. So this is in the bottom, minus log of x, minus log of the square root of y. All right, because x and square root of y were both in the bottom, so we just subtract both of those. Then we can use our exponent rule. So if you have a cube root, hopefully you see that that's going to be raised to the 1/3 power, so we can bring 1/3 out front. There's nothing on the x. And then we already talked about how that would be a 1/2 for a square root. Good, and that's our answer. Now, if you do it step for step, this is where you might get a problem when it comes to part B. So here's your example of how you might get a problem. So if we used number 2, for instance, first, and we did log of this cube root of z minus log of x square root of y. And then you see, oh, well, this is multiplication. So number 1, right? And so what you write is log cube root of z minus log of x plus log square root of y. Well, now we got a problem, right? If you notice, this is not the same thing. And the problem is because you were subtracting the whole thing, which means you need parentheses here. And that's what students typically forget about. They forget about these parentheses, and so they forget that they actually have to distribute that negative, right? So that's, again, that's why I say, and this is the way that I do it, if it's on the top, you add. If it's on the bottom, you add, so positive. If it's on the bottom, you subtract. Just an easier way of thinking about it, I think, at least. All right, let's do the next one. Okay, so the entire thing is being fourth rooted, right? So can't split up yet. So there's a couple ways you can do this. One is just to distribute this fourth root to all the different exponents. So we could have ln of x raised to the 7/4 power, right? Because remember, fourth root is the same as 1/4 over y to the 5/4 and z to the 1/4. This is how I do it. Again, if you want to do a different way, that's totally okay. I can show you a different way, but I feel like this probably has less ways of messing up doing it this way. So distributing that cube root. All right, and then we just do what we did, right? So we can do number 1 and number 2 at the same time. Everything on the top is positive, everything on the bottom is negative. So natural log positive natural log of x to the 7/4 minus natural log of y to the 5/4 minus natural log of z to the 1/4, because both of those are in the bottom. And then you can just bring out all of the exponents, right? So 7/4 natural log of x minus 5/4 natural log of y minus 1/4 natural log of z. All right. So the other way that you could do it is you could get rid, or you could bring out the 1/4 first. All right, so you could do 1/4 natural log of x to the 7th over y to the 5th z. The thing that I see most likely to occur for students is when you distribute for the next rule, right? So using number 1 and number 2, I see 1/4 natural log x to the 7th minus natural log of y to the 5th minus natural log of z, right? But again, we are taking 1/4 of this entire thing, which means that 1/4 is being multiplied to all of that, right? So again, another potential for an easy error that you could rectify by doing it a different way. But you could do 1/4 natural log of x to the 7th minus 1/4 natural log y to the 5th minus 1/4 natural log of z, right? And then just bring those exponents out. And then you end up with the exact same answer. So again, if you would like to do it this way, that's totally okay, but there is a potential for error. Whereas the way that I do it, not really going to be too much room for error like that. All right, now let's do the exact opposite. So let's express the following as one simplified logarithm. So if you notice, we're doing 1 and 2 and then 3 first. So now we'll just have to go backwards, right? So we'll need to do number 3 first. So we'll put all the exponents on the logarithms. So we get log base a of the cube root of x squared minus 1 minus log base a of y minus log base a of z to the 4th. And now that we don't have anything in front, now we can combine all of them. And again, I think it's just easier to do it the way I said, right? If it's subtracted, where's it going? On the bottom. If it's positive, it's on top. So for one logarithm, right, it's the cube root of x squared minus 1 over y times e to the 4th. And that's your answer. So I will say that when I see this, a lot of times the reason why this might be a mistake for students is that people will write log base a of the cube root of x squared minus 1 over log base a of y z4, right? That is not correct, right? It's just one logarithm. So make sure that that is not what you are doing. You're putting it as one logarithm when you combine them all. All right, part B. So let's do the same thing. So we're doing number 3 first, moving all the exponents out front. So, or other way around, taking from out front. So we get x to the 5th minus log base 2 square root of 3x minus 4 minus log base 3 of 5x plus 1 cubed. And then again, anything that's positive, we're going to do number 1 and number 2. Going to go up top under the 1 logarithm. And then anything that's subtracted goes in the bottom. So square root of 3x minus 4 times 5x plus 1 cubed. All right, and then last one, part C. All right, so let's do number 3, right? Bring all the exponents out, or from out front. So we got log x cubed y squared minus log of all of that being squared minus log of all of that being cubed. And if you would like, you can simplify first. So we get log of x cubed y squared minus log. So this is going to be x squared. And then, I mean, we can already put this in the regular exponential form because we'll have to simplify things later. So that would be 2/3 power minus log of x cubed over y cubed. All right, then we do number 1 and number 2. So under one logarithm, the common log, we get x cubed y squared on top, x squared y to the 2/3, and then x cubed over y cubed. All right, but we can simplify more than this, right? So we get log of, so if we want to simplify things a little bit, so on the bottom we get an x squared and an x cubed, so that would just be x to the 5th. You add those two together, and then you get, then you get y to the 2/3 and y to the 3rd, which would be y to the negative 7/3. Yeah, right, because this y is on the bottom. Good. So, simplifying it more, right? We can move the negative exponent on top, so we get x squared, y to the 7/3 over x to the 5th. So, since 5 is on the bottom, the easier way I think to do it is do 5 minus 2, which is 3, and put that cube on the bottom. And then for the y's, you have 6/3 plus 7/3, which is going to be 13/3. Oh, there should be a cube up top. All right, that was the problem. Yeah, cube up top, which would be a square on the bottom. There we go. There we go. All right, so that'll be the answer. All right, let's solve some equations. So we can see, right? Remember, one way to solve logarithms is to have log of a base equals log of the same base. We don't have that right now, right? We have an addition. So how can we combine these two? Hopefully you can see that's from law number 1, right? So we get log base 5 of 2x plus 3 equals log base 5 of 3 times 11, which is 33. We can drop the logs, so we get 2x plus 3 equals 33. So then 2x equals 30, x is 15. Do we have to check ourselves? Yes, we do have to check ourselves, right? We got to plug it in at least into what everything, all the x's that have logarithms of, right? So, check 2 times 15 plus 3, that's 30 plus 3, which is 33. That's bigger than 0, so we're all good. 11, there's no x. 3, there's no x. Okay, so that is our final answer. All right, let's do it again. So we can combine these two using law number 1, right? So that's going to be log base 2 of x times x plus 2 equals 3. So we don't have log of a base and log of another base. So what's the other thing that we could do to solve these problems? So hopefully you remember that we could snail it up, right? So we can do 2 raised to the 3rd equals x times x plus 2. So 2 to the 3rd is 8. X times x is x squared. X times 2 is 2x. So we put all of them on one side of the equation. Right? What two numbers multiply to get you negative 8, adds to get you 2. And that's going to be positive 4 and negative 2, right? So then that means x is negative 4, x is positive 2. All right, so we gotta check ourselves, right? So we got log of just x. So checking -4. -4 less than 0? Yep. So -4 cannot be an answer. 2 is greater than 0, so we're all good there. So we gotta check the other one, right? So x plus 2. So 2 plus 2 is 4. 4 is positive, so that's okay too. So we see that our final answer is x equals 2. So notice it is not because specifically -4 was negative, right? You can have negative answers. For instance, if we had log of -x, right? Then 2 would have been the one that wasn't correct. Right? If we had log of -x, then -4 actually would have been okay, right? That would have been a positive answer. -4 would have been 4. That would have been okay, right? So don't just automatically say, oh, it's negative, that can't be the answer, right? It's the same thing as 0, x being 0 for a denominator, right? Well, if it's x plus 1, well, yeah, x can be 0, right? Because that would just be 1 over 1, which is 1. So yeah, just because x is negative doesn't mean that it automatically can't be an answer. You need to double check yourself. All right, number 5. So natural logs, right? So this would work the exact same way, so we can combine them. So we see that for this case, it's going to be number 2. So on the left side, for one logarithm, it's x plus 6 over 10. Right side, for one logarithm, x minus 1 over 2. We can drop the logs because we have the same base, right? And the base would be e. So x plus 6 over 10, x minus 1 over 2. We can cross multiply, right? So 2x plus 12 equals 10x minus 10. So we can subtract the 2 to one side to get 8x, add the 10 to get 22. So we see that x is going to be 22 over 8, which is 11 over 4. But, of course, we got to check ourselves. So we got to check with x plus 6 and x minus 1, because there's no other x's in these two. All right. So 11/4 plus 6, regardless of what that is, we can definitely see it's positive, right? Which is really all we need to check. So then we got to check x minus 1. So that's 11/4 minus 1. We see that's going to be 4 over 4, right? So 7/4, still positive. So we can confirm that x is 11/4. All right, last problem. So let's do a quick sketch of this using our rules for our laws of exponents. Sorry, laws of logarithms. My bad. So let's get a little bit better idea of what this is going to look like. So since we are multiplying, right, we can use law number 1 and say that y equals log base 3 of 81 plus log base 3 of x. So let's see if we can break up 81. So 81, we know that's 9 and 9, which is going to be 3, 3, 3, and 3, right? So 81 is 3 raised to the 4th power. So we can rewrite that as log base 3 of 3 to the 4th. Now, going back to our laws, right? Which one could we use to simplify this term? Hopefully you saw that that's going to be law number 6, right? And that just simplifies down to y equals 4 plus log base 3 of x. Now we can do a quick sketch, right? Because we know log base 3 of x is just going to look like this, right? So if we add 4 to the outside, what happens? Well, we just go up by 4, right? So this is what it will look like. Asymptote still at x equals 0. Good. All right, and that's it for this section. So if you have any questions, let me know. Otherwise, have a great day.